Example 2, we want to find the critical value for a left tail test with alpha equal 0.10. Degrees of freedom in the numerator is 15 and the degrees of freedom in the denominator is 50. And then a portion of the table of critical values of the F distribution is provided. Now, one of the key words that we need to look at is the fact that this is a left-tailed test. Okay, so because it has a left-tailed test, it says the critical value with an area of alpha, which is 0.10 to the left, has an area of 1 minus 0.10 is equal to 0.90 to the right. So that means that when I draw this picture, here is what my distribution looks like. And on this side over here, this area represents 0.10. And then the area inside here represents 1 minus 0.10, which is equal to 0.90. So that is this number here. So what we want to be able to do is we want to be able to find this critical value here that is going to be the F critical value at 0.90 with the degrees of freedom in the numerator be 15 and in the denominator it is 50. Now on this side, this would be the area of 0.10 with the degrees of freedom in the numerator be 50 and then this to be 10. So what's going to happen here is that in order for us to then determine how to go about this, you can see this is the formula. So since the table does not give critical values with an area of 0.90 to the right, we're going to use the property that is shown below. So here we have F, this is 1 minus 0.10, and then we have N1, which is the 15 degrees of freedom, and N2 minus 1, which is the 50 degrees of freedom. And what that's going to equal is, it's going to be 1 over F, the alpha is 0.10, and then we're switching the degrees of freedom, so now this is going to be 50, and then this is 15. So now what we're going to do is we're going to use this information here. So what's going to happen is we're going to come down here, okay, and then we can see that the degrees of freedom in the numerator is 50. The degrees of freedom now in the denominator is 15. So let's go ahead and look at that. So here is 50. And then we're looking at 0.10. And so we should see that the critical value is 1.83. Now we're going to use that number 1.83 and put this in the denominator because that's going to be 1 over 1.83. And then we need to go ahead and find the result of that. So 1 divided by 1.83 reduces to 0.55. So therefore, this is the critical value here, which is 0.55. And on this side, this would be 1.83.